Hello and welcome to windPRO tutorial. This is part 4 of our comprehensive windPRO tutorial. In part 1, 2, and 3, we managed to have an extension for an existing wind farm, Westfield wind farm in the UK. We have managed to define 2 new wind turbines and add them to the existing ones. And we did some environmental and visual assessment in terms of noise, shadow flicker, and we did some photo montage as well. So in this episode, what we are looking for, we're going to take a look at energy calculation and also some financial modeling and calculation as well. Before we start with the software, I would like to discuss a little bit about the concept and theory behind what we will do in windPRO. So as a basic equation of energy for wind turbine generators, we can report them or formulate it based on the power output as a function of air density, wind speed, swept rotor area, and efficiency of wind turbine generator, which itself is a function of wind speed. And as we know, the power would increase with the square of the rotor diameter and also the cube of wind speed. Now, what is interesting to discuss here is to take a look at a graph on the right-hand side, which comparing the 2 different wind turbines designed for low and high wind speed conditions. You can say that at moderate wind speed, the turbine operates near its optimal efficiency, and the cubic relationship between the wind speed and the power generation would hold reasonably well. However, at higher wind speeds, the turbine may need to reduce its power output to avoid mechanical stress or damage by blade pitching or braking, and this would limit the efficiency for us and consequently the energy output. With this in mind, we know that the annual energy production, AEP, increased with the average wind speed, but not with the cube due to its dependency of the efficiency on the wind speed. As a rule of thumb, we could say that 5% more wind speed will result in 10% more production. So I would like to also discuss about the power curve and wind turbine generator efficiency curve. So the red curve in this graph is a power curve of the wind and is converted by the wind turbine according to the power curve. So this red curve basically shows us how much we can generate power from these wind turbines depending on the wind speed. So this one is specifically this wind turbine designed for 1,300 kilowatt specifically. What about the red? What about the green curve? So the green curve would be or efficiency, and it shows the efficiency with which the wind turbine converts available wind energy into the electricity. And obviously, we have a limit which we called as a Betz limit on all wind turbine generators. So the power curve can either be calculated by the manufacturer before we build the turbine, or it could be measured by professional measuring institution in the field. Also could be estimated from simple parameters based on the rotor diameter, rated capacity, and control mechanism type. So what we're going to do today, we're going to use the GASP data. And the GASP data is developed by DTU Energy, Technical University of Denmark. And GASP Global is a short for GASP 1.0, which is again short for Global of Atlas of Sitting Parameters. And we can look either online, and this website, Global Wind Atlas, will give us wind resources map across the world and also offshore as well. But also we're going to be able to download it through windPRO software. For onshore wind speed data, it's more or less optimistic, around 15% more in wind speed. But for offshore, it's almost quite accurate data from this website and also from this resource, which is the GASP resource. So we can also define the energy production by simply multiplying the power curve and the wind distribution and summarizing it. So we can say that annual energy output would be power curve multiplied by wind distribution. And if these are known and precise, we are on the right track. But also we need to remember to incorporate losses, including array losses, grid unavailability, which we will discuss later on as well. So the Park module in windPRO software, we will use this module, and the Park module combines two calculations in one step. So basically, it does the annual energy production value for us. So how much we can get from the wind farm. So applies a wind distribution to each wind turbine generator and give us the annual energy production. And also it calculates wake losses for us. So how much is the wind reduced by the neighboring wind turbine generator? What is wake loss? If you look at this image from an offshore wind farm in Denmark, you could understand that. So because when we are having a wind turbines and when we have a wind resources, passing through each wind turbine, the energy will be absorbed and will be received by those wind turbines, and the following wind turbine generator will receive reduced value of this energy. So in order to be in a safe side, we need to keep a appropriate distance from each wind turbine to be able to reduce this wake loss or even make it zero. So we have different options in Park module in windPRO. But we're going to use the standard Park with resource file module for doing this AEP analysis. The other ones you can explore by your own as well. So we're going to work based on the wind resource grid, which we called WRG as well. And it basically contains wind parameters for an area on the regular grid. So it's not high resolution, high detail data, but it's good enough for us. So the resolution is around 250 meter, and it can do heights of 50, 100 meter, and 150 meters. And this was the reason that we selected top height of the wind turbines carefully before in the part 1 and part 2 of this tutorial. It can be downloaded for free using windPRO for using the Park module. And it basically covers a very huge area, so everywhere. And if you want to know exactly, even it could covers the land and up to 200 kilometers offshore across the world. So from the Persian Gulf to, as I said, lots of areas in terms of the offshore areas as well. So we need to, as I said, we need to download the GASP data, global of atlas of setting parameters, which was, as I said, developed by DTU. So we need to download it in order to be used in a Park module. And in terms of the wake effect, so as I described before, it's a reduction of wind speed downstream of the rotor, and the area of added turbulence would result, if we don't follow this, increase in the fatigue load and also decrease the lifetime of the wind turbines. So the wake model in windPRO, we have different models that windPRO uses to work and understand the wake model. The first one, which is the Jensen model 1990, developed in 1996, is based on the linear expansion and is most conservative model. But we have other models which have been developed over the time as well, which follows different boundary conditions such as Navier-Stokes equations, etc. What we're going to use, it's called Park 2, which basically is based on Jensen 1996 model based on the linear expansion. It was developed in 2018, and it's basically an improved version of the 1996 model. It's especially suited for large parks and vague surface interaction disregarded. And basically what it says this Park 1 and Park 2 model is based on the Jensen model. It says that in a straightforward, so parking model in this way is a straightforward linear model, which assumes that the wake reduce or decay in a linear fashion. It's not the most accurate one, but it's good enough for us to doing our calculation today. So as they spread out, they are also recovered gradually, and over the time, the deficit reduced and returned to the balance. So in terms of the wind speed, as I said, energy from the wind will be received by the first wind turbine, and the following wind turbines will receive reduced amount of this energy if they are so much close to the first wind turbine. It can be described by this model, and windPRO is also using this Park 2 model. Each model has their own wake decay constant, as you can see from the formula alpha, and which basically describes the widening of the wake cone downwind of the rotor. Recommendation from the developer, Technical University of Denmark, for Park 2 is for onshore we use alpha of 0.09, and for offshore we use 0.06. Other models are available for wake decay constant, WDC alpha, so you can pick them based on your preference, but we're going to use what we have for the DTU default onshore WDC of 0.09 because our case or wind farm is onshore as well. We're going to keep everything default. We're going to select the model. We're going to select the decay constant model, and hop height for the key results is going to be based on 50 meter, which we know from the part 1 and part 2 of tutorial. We're going to assume 10% additional loss, and this loss would be based on other factors beyond the effect of the wake loss. So because the energy could lose in transmission or down the tower or through the cables, through the ground, and finally substantial. So it could lose in other areas as well on top of the wake loss, such as the dirty blades, ice buildups, and other similar issues will result in an extra loss. And when we take to consideration all of these, it would be accounted for around 10%. We're going to select our wind turbines as we did in the previous sections. And finally, we will download and load the GASP data, as I said, global of atlas of setting parameters, and then we will use that for our AEP calculations. If you want to read more about this in windPRO knowledge base, you can refer to section 3 of online help or knowledge base, and you can read through as well. Now, again, it's a time for us to go back to windPRO software and start to do some AEP analysis using the Park module and do a little bit of financial calculations as well. So first thing first, coming back to the software, so what we need to take a look at, maybe I could for now turn off the camera layer and add all the wind turbines again active in the object layers, both existing and also new wind turbines layer. So I need to first download the gas plus data for our site. Basically is global of atlas of setting parameters data. In order to do that, I need to navigate to climate tab over here, and then I would click on setting parameters GASP. If I click on that, it will ask me to download it. So EMD GASP data is my interest. Others are available as well. but we're going to use here the GASP data. The resolution for downloading, it would be 20 kilometer by 20 kilometer, which is absolutely fine. And the positioning is the default center of our site, which very similar to what we have done with the other modules as well. I'm going to click OK. And it will take some moments, but it will download it automatically for us. I'll back once it's downloaded. Okay, now as you can see, it's now says that the download is completed. I click OK. Now I have a new layer in my result layers as a GASP results. I can turn on and turn off this. I would like to do some zoom out so you guys could see the area. So remember that we have defined as a 20 kilometer by 20 kilometer. So it's going to be the same for this. Even I can double check this if I want, but I mean, it should be the same. I'm going to use the ruler, and as you can see, it should be around 20 kilometers visitages. So what needs to be done? I would like to delete this ruler because I don't need it, so just for demonstration purposes. Okay, so I have now the GASP data downloaded and available for me. What I need to do now, I need to now navigate to Energy tab over here. On Energy tab, I have a module called Park module. I will click on that. I will run the Park module for me. From the main tab, so I would perhaps need to put a name for this calculation similar to previous one as well. I'm interested to do, again, 5 old wind turbine generators and 2 new wind turbine generator. That would be the name. Remember from this slide, we're going to use standard park with resource file. So I'm going to select that one. And it's going to tell me which kind of model I would like to use. I will use the Park 2 model, as I mentioned before. For alpha parameter, which is the vague decay parameter, I will use what I have from the onshore wind farm, which is 0.09. And I do like this. Okay. So as I said, from the main, I pick the model going to, again, similar to everything that we have done so far. In windPRO, we are navigating from left to right. From the setup, all of them needs to be unchecked. I select the model. I select the alpha value. Going to the wind turbine, I can select, remember from the previous modules, which wind turbines I would like to include in the assessment. I will keep all of them because I would like to see the AEP of both existing layer and also new layer of the wind turbines. In terms of the resource file, nothing is loaded, so I need to add. Remember, I have downloaded using the climate tab. So once I click, this window will pop up and I will have the gas data. I just need to double click or select and then click OK. And it will be loaded here in terms of the resource file as well. Nothing will be changed in terms of the displacement, height, power correction. So everything needs to be as it is. I would like to also discuss a little bit about cost assessment as well in this case. So if I use cost calculator, it will do some cost assessment for me as well. Different model is available: wind onshore with mid-end cost model, wind offshore with mid-end cost model, and general cost model. Because our case is onshore, so I will use wind onshore mid-cost model. You can define your discount rate and also operation years. And what it considers is that it's going to start from 2026 as an investment year, and it will be in operation from 2027 in 2 years. So currency at the moment is euro. I can set up currency and also other parameters as well. Okay. So as I said, the model that I'm looking for to do now is a mid-end cost wind onshore model. I can edit the currency from here to any currency that I want. So I can select, because we are doing UK, I will select British pound. I will select OK, and OK will be changed to British pounds. What else? Everything in this table is based on this mid-end cost model, but if you wish, you can also modify all of these parameters if you have done some surveys as well in terms of the capex cost, etc., or opex cost. And as I said, all other factors can be modified as well, but we leave it as model suggested. Perfect. You can also define a new model if you want your own model, which you need to fill out all of this info yourself. Nothing will be changed in terms of other parameters. So I will click OK for a cost. So it will follow those outputs for me. And the hub height will remain as 50. Remember what we have discussed previously that we are interested to see for 50. So that will basically do all those calculations for me. As I said, you can add some description as well, but you don't need to do anything. Now I will click OK, and it will run the calculation for me. Remember from previous assessments that it will ask me if I want to wait or not. I will click yes, I don't want to wait. So we'll run calculation. Once it's done, I'll be back and then we will discuss based on the results. Okay, now I have in my calculation tab, I have also part 5 old wind turbine generator and 2 new wind turbine generator results. And what I could do also in the EMD gas data, I could right click on that, show legend, and it will basically show me what would be the wind speed regarding to this map. As I said, it's not the most precise one because the resolution is not the highest one. It's 250 meter resolution data. Okay, so now it's time for us to analyze the results. So remember from the previous modules, I need to, in calculation side, I need to right click on my result, and then I would print that result. If I click on print, it will bring me this window, which is what we have discussed previously. I can preview this result or generate it as a PDF file any way that you guys prefer. But at the moment, we go with the preview the result, which is in my second screen. So I have to be able to move this to this screen as well, if I could do perhaps. So yes, brilliant. So I have this now, this preview of results over here. What I need to do now, I need to now review the results. So if you take a look at calculated annual energy of wind farm, you see the results for wind farm, new wind turbine generators only, existing park from wind turbine generator only, and basically the details for this. On this table over here, what is interesting for me to see is, so I have results as a park, megawatt hour per year in terms of annual energy production AEP. And as you can see, I can see the overall wind farm AEP. And in gross is basically considers without any park loss. So this one taking into account park loss. Gross, there is no loss due to the park loss. And then here is the wake loss that I have. So 5% or 3% or all those values. Then I have capacity factor, which means that how effective the turbines are. So how much energy are produced in comparison to the maximum rating. So 43%, 53%, 27%. And in terms of the results, it also includes that 10% of other parameters that we have discussed previously. I also could see the main wind speed over here, meter per second at hub height. So it's 7.4, 8.5, and 6.9. And as you remember from our previous discussion about the gas data, which they are 15% optimistic as well. And if you take a look at the row says existing park, wind turbines only, you could see around 15,000 megawatt hour per year. And if you compare this with what we have discussed from the site visit previously, it should be around 10,000 megawatt per year on average. It's around 5,000 more, and that's mostly, as I mentioned before, is coming from the reason that the gas data take to account 15% more optimistic values in comparison what in actual case should be. If you scroll down to the next pages, so you could see from the report different results as well. You could see, for instance, from the results, so you're going to have 13 page of results. So you would be able to see the values for each wind turbine. So for instance, on this one, for all 5 old wind turbine generators, 1 to 5, you could see them, which they are a bonus 1.3 megawatt wind turbines. And in the next page, you could see the production analysis. And this graph is particularly interesting because what we can see is you can see the energy, annual energy, and also vehicle loss in comparison to them. What else you could see? So if I scroll to the next page, again, same for curves as well. So you can get the power curve and efficiency curves as we have discussed in previous slides as well. And you would get an info on wind and wind resources and the energy production in respect to that. You could get some park power curve data as well. And finally, you could get also your cost analysis too. So one thing that you need to remember, this cost, it doesn't include any revenue. So it's only regarding to the cost. And you can get your levelized cost of energy as 27.96 pounds per megawatt hour. You can then use this data to do some cost analysis, a summary of the considerations, and also parameters would be here as well. You could finally get the map of your 5 existing and 2 new wind turbines. And as I said before, you can also copy to clipboard. If I close this window, I could also generate the result based on result to file. So if I click on result to file, so just to repeat, on the calculation window, on each of these results that I'm interested, so for instance, in this case for park, I could right click, and instead of print, I could do result to file. And what it could do, basically, it could give me the results based on the different formats, is an Excel format, etc., etc. What I need, for instance, at here, I need park results. I will copy to clipboard these results, and it will tell me that the data are copied to clipboard. If I open an Excel, blank Excel document, what I could do, I could basically take all of those data and just do Control V, and it will be copied in this Excel file, and then I can work with these data as well. Okay, so this is the end of part 4 of our windPRO tutorial. I hope that you guys enjoyed it, and we have covered basically all aspects of wind farm analysis in terms of environmental assessment, energy generation, noise, shadows, ZVI. We managed to do photomontage as well. And that's it. For the next video, I'm planning to do some lifecycle assessment using windPRO software, and that should be the next video. Thank you very much for watching this video. Catch up with you with the next one. Have a nice day.